In this demonstration, we present Mocha, a tool that facilitates exploration and visualization of the impact of alternative physical operator choices on a selected query execution plan for a given SQL query in PostgreSQL. As we shall see in the demonstration, exploration and visualization of the impact of alternative physical operator choices can aid learning. We use the TPCH dataset and benchmark queries which have been chosen to have broad industry-wide relevance. First, we set up the connection to the TPCH dataset which has been preloaded to PostgreSQL. Once the connection is set up, you can input the TPCH query into the query panel. We now copy and paste the SQL for query 4 of the TPCH benchmark. Next, we configure Mocha to generate the alternative query plans by using the middle panel highlighted in red in order to generate alternative plans. Mocha exploits the planner method configuration feature of PostgreSQL to force the query optimizer to choose a query plan based on the parameters. Mocha provides two modes of generation, namely single alternative plan and multiple alternative plans. We now demonstrate the single mode. In this mode, Mocha sends a query request to PostgreSQL in which the unchecked parameters are set to false to generate an alternative query plan containing the operators corresponding to the checked parameters that are relevant to query processing. When the query plan button is clicked, Mocha sends two query requests to PostgreSQL. The first query is a query with default parameter settings, and the second request is one with unchecked parameters set to false. Note that the former request retrieves the QEP, whereas the latter request yields an alternative plan AP1. In the results panel, Mocha summarized the total cost of the selected and alternative plans in both text and bar chart formats for easy comparison. Here the total cost of the selected and alternative plans are 162K and 10 billion cost units, respectively. The plausible reasons for choosing QEP are likely due to the following. First, the predicate of line item table has high selectivity which makes index scan online item a better choice. Second, the predicate of orders has low selectivity which makes sequential scan likely to be faster on orders. Third, the use of nested loop joins is efficient for this particular query, since the join input from orders is 5 rows and considered small. Next, we shall demonstrate the use of multiple plans mode. In this mode, every checked parameter are either set to true or false to create all possible combinations of these parameters. The number of parameters considered has been set to 6 by defaults in Mocha. Mocha first submits the query with default parameter settings to PostgreSQL to retrieve the QEP. Then the query with each parameter combination is submitted in turn to retrieve alternative query plans. Only distinct plans are maintained in Mocha. In this example, there are 7 distinct alternative plans. We now take a look at AP5, which has very similar cost units as the QEP. In AP5, index scan replaces sequential scan on orders, resulting in a slight increase in cost units. Comparing QEP and AP5, we observe that for this particular query, both index scan and sequential scan are suitable for orders. Now let's take a look at AP6. In AP6, 2 additional modifications occur in the QEP, namely replacement of nested loop join with hash join and the introduction of the hash operator on the index scan of line item. These additional changes resulted in a 122K-fold increase in terms of cost units. Hence, Mocha allows the users to easily compare between the QEP and possible alternative plans and to examine the effect of changing particular operators in the query plan. Mocha provides intuitive explanation why key operators in a QEP are chosen by connecting them to established knowledge in the literature. This facilitates a learner to intuitively comprehend why a plan is chosen as a QEP. Further, the visualization of the query plans allows quick comparison between plans to examine the effect of using different operators in terms of cost units.